micro adventures. And after you've eaten the marshmallows and the stars come out, you can reflect a little bit on life. During the day when I work, I kind of have the same passion. Open source to me is freedom, way of sharing ideas, being part of a community, and those are the things I value most, and that's why I work for Red Hat, and I have been for the last 15 years. I started at Red Hat in middleware, doing J2EE and ESB, sort of like technologies that grew out of the internet, and the internet, had been around for 5 years or so, but by then, finally, it spawned application servers and really server-side frameworks that you could build big applications on. Now there's another revolution going, which is the cloud. So the cloud's been around for about 5 years, and now you really see that the frameworks are coming about. So platform as a service is sort of like mainstream at the moment. You can automate shipping, you can automate deployments, you deploy to containers and you orchestrate it with Kubernetes. And what I'm working on is an IPaaS, which is an integration layer on top of the PaaS. So as I see it, if you get the IPaaS, you'll get all the features of a PaaS, plus you get integration. So we don't turn any features off. At Red Hat, we use Docker for containers. We use OpenShift for orchestration. And OpenShift is a Kubernetes implementation, as I already said. Kubernetes is started by Google, and Red Hat joined early on as a full partner, and we are contributing to this ecosystem. So we have a lot of developers who contribute back to Kubernetes, to this Kubernetes specification. Quickly, I'll do this faster than usual. On the left is a virtual machine. On the right is a container. So the difference between a virtual machine and a container is that in the container, the kernel is shared, right? So on the left, you can have a Windows machine running on CentOS because they both run their own kernels. On the right, that's not possible. You have to have a Linux-based distribution. So on CentOS, I can run Ubuntu or I can do Debian, but I cannot run a Windows. Okay. On top of being able to start and stop containers, which is really starting and stopping processes, right? What the next thing you need to have is an operating system. So the same as you have an operating system for a computer, Kubernetes is the operating system for a cloud. So here is a high-level picture of what OpenShift, of what Kubernetes would look like. In the red are hardware. So there's 2 master nodes, and then there are 6 regular nodes. These are the worker nodes. So the worker nodes run containers. Containers are scheduled inside of pods. That's the Kubernetes terminology for packaging up one or more containers. The masters then schedule work on these nodes. So how that works is that they send metadata to one of these nodes, and part of that metadata is, hey, start up this container. The images of the container live in the registry. So it pulls down everything from the registry. So this is a Docker registry. You usually have a private registry at your deployment, and then there's a public one, Docker Hub, where the base images live. Storage-wise, the containers should be immutable. If you want persistent storage, you have to mount it into the image. So it's never part of the image. So Kubernetes will give you a volume on startup, which means that if your pod goes down and another one comes up, they'll look at the same data. So you don't lose any data. The power of OpenShift versus Kubernetes is that Kubernetes only runs in the cloud, while OpenShift can be run locally as well. So I can deploy OpenShift on my own servers. So it's an on-premise installation as well as a cloud installation. So I can deploy OpenShift to Google, or I can deploy it to Amazon, but I can also deploy it locally. I actually have it running on my machine, which is great because now you have this hybrid sort of cloud. And if you, some applications you really don't want to have in the public cloud, and you're ready to share them or scale them up whenever you need to. I know. Applications from outside will go through a routing layer. So like these mobile platforms and stuff will go through a routing layer before you can access the internal network. So the internal network is always shielded from the outside. All right, what does it mean to develop straight on Kubernetes, right? What kind, obviously you're getting, automated deployment, automated operations, scaling of applications, but there are certain patterns that your container, your software should adhere to. One of them is, for instance, liveliness and readiness probes. So as your app is coming up, Kubernetes is just trying to see, hey, yeah, I know the container's up and running, but your process is still initializing. So you should have a readiness probe that once that comes back as true, Kubernetes knows this pod is ready to receive requests. And then it will be put into production, not before that. Liveliness is the same thing, but then over time, if the pod becomes unresponsive, then Kubernetes will decide to kill it off, and a new one will be started. So that way, hopefully the problem will resolve itself. Other interesting features are config map and secrets. Configuration really shouldn't be part of your container. It shouldn't be part of the thing you ship. It should be part of the namespace. Because if I have a staging namespace and a production namespace, my configuration is probably the difference between the two. So when I move my container from staging to production, the container is the same, but I'm getting a different config map. And so I'm getting different configuration. The same with secrets, like database passwords and stuff like that. You want to connect to the production database in production, and you want to connect to the staging database in staging. So those are things you should take care of from the start. All right, so what we did is we built an IPaaS based on Camel. Camel's been around for, 10, 15 years. There's over 200 components connecting to different end systems, like, a file system, JMS, SQL, database, Mongo, Twitter. There's all these connectors. So what we're doing is we're taking an Apache component, I have to be specific, component, and we're adding a little metadata around the component and then making it a Syndesis connector. And the connector knows, for instance, the data shape of the data coming into the connector or going out of the connector. So there's a contract. There's like a schema file you can upload as to what the contract is. The second thing Syndesis adds to Apache Camel is that it creates an integration. So it creates a full application from, let's say, Twitter to a database. So it listens to Twitter events, and then it pushes that into a database. And this full application is built and deployed into the cloud. So we're using templates like Maven templates and Maven POM files that as you are selecting components, it pulls in the right application component, Apache components so that you get the right tar files and stuff like that. All right, so then it publishes off to the cloud. Finally, we like to engage users of all levels. So we'd like to engage novice users, like people who are not very technically savvy, like maybe they do know the domain very well, like a business analyst, but not people who are experienced developers. So we'd like to, in this UI layer, make it very simple for people to use it. But we also don't want to scare away the developers who are expert users, so we're having an extensible framework that allows you to add your own components and extend synthesis. And hopefully, these two user populations will bridge, so expert users can help novice users and develop components for them. Our development process is such that we have two upstream projects, being OpenShift and Camel. So we have about 20 developers working on it, but they share that time on the upstream projects. So we contribute code back to Camel as well as to OpenShift. It's questionable how much code, or how much of a community Syndesis is going to have. Because really the Syndesis project is very thin. It's only like a UI layer on top of Camel. And the people who will be using it will be the business analysts, sort of. So I'm not sure how much of an open source community this will have, but 80% of it is OpenShift and Camel. So that's more where our community is, I think. Okay, so the UI, we decided should be UX driven. So we don't want Camel developers in the meetings that develop this UI, because they're going to bring in Camel concepts, right? And so before you know it, it's going to be, a Camel application. And we really want it to be an IPaaS. We want it to be fresh. We don't want it to smell like something that is difficult to use.
You don't want to smell like Camel.
Exactly. Every PR, every pull request creates, when it's merged, creates new Docker snapshots. So all the containers that are affected are rebuilt and pushed up to Docker Hub. So each developer has a local OpenShift called Minishift on their laptops. And in 5 minutes, I can destroy it and rebuild it from scratch with the latest snapshots. And that's great because now we are 100% sure that you have an identical environment that I have. So that's, whenever someone has a problem, they say, refresh it before I'm even gonna try answering your question. And we know 100% sure at that point that their environment is the same as mine. So that's awesome. Another interesting thing we did is that the UI is Angular UI. And so it's a single-page application, which then makes REST calls back to the backend. So there's JSON flying back and forth through REST interfaces. And there's really not that many objects, and all the objects are directly stored in JSON into the database. So there's no mapping layer or anything, which is kind of unusual. So we really hard code the backend to the front end. But it seems to work really well, because if you're developing components, you can just make up the data, basically, the new components data, put it in a file, read it in, so the UI can start working on it while the backend is still being implemented. It's a very, very simple way to go about it. All right, this is really the whole data model, right? The integration is a series of steps. A step can be an action or a connection, and a connection, there could be many instances of a connection, because a connection is a configured connector. So if I add credentials to a connector, I have a connection at that point. Then a connector can have many actions. So when I connect to Twitter, I can say I want Twitter search or Twitter mention. Those are two different actions. So if a connector has two actions, your action framework, your step will have a choice of two actions as well. All right, these are the 6 pods we have in the system. So there's 6 pods that make up the entire IPaaS. On the top, there's an OAuth proxy. So all requests will always flow through the OAuth proxy. In the beginning, you will be doing a little OAuth dance with the OpenShift server. So user accounts on OpenShift are the same as they are on the IPaaS. And once you are in, requests are then relayed to either load the UI once into your browser, or the UI then making calls, your browser then making calls to the REST API. So the Syndesis server really is where all the work happens. And then the Syndesis server can persist, the objects into our database. So we ship a local database. And on the left, you see Syndesis meta. This is a pod, sort of an enricher pod, so it can introspect connections. So it can see if a connection is correct, if the credentials are correct, or it can, if it's a database connection, you want to interact with store procedures. It could bring back a list of store procedures. You can pick one. And then finally, on the right here, for metrics, all our integrations write their metrics to Prometheus, and then the server can make requests to that Prometheus server to display metrics about that integration. All right, here is meta pod one more time. I'm not going to talk about it. This is interesting, I think. So this is a single page web UI in the front, talks over the JAXA resources, talks JSON directly into the JSON database. We have an event bus, so if objects change, we can push them back into the browser using server-side events. And then here on the right is a custom Kubernetes pattern. So Kubernetes comes with controllers, but you can build your own controllers as well. So here we have a controller that listens to events going into the database. So if you want to publish an integration, that publish event is found, and the controller starts to talk to OpenShift. So this integration controller then basically takes an integration from the database, and it starts an OpenShift to build. So we actually have a build pod on OpenShift in which we start putting all the information until the whole pod is correct, and then we snapshot it and we spin one up. This is what an integration pod looks like. So there's several layers on the bottom. CentOS and JVM is basically the base image. And then depending on what kind of build you're creating, we're deploying Spring Boot Camel, a Syndesis runtime, and then the user's integration. This is an adapter pattern as well, because we ship similar components like JMX components, so that the little agent in the CentOS runtime can push the metrics to Prometheus. And so all our integrations will do that. And we will also push logging to OpenShift console logging. So we're not gonna go into the pods themselves to get the logs. No, we directly talk to OpenShift. When we get all the logging, and then we filter out what we want. Okay. Who's ready to raise the camel into the cloud? I'm gonna try to build an integration on the fly. And hopefully you guys can help me by tweeting this keyword, and hopefully it's going to pick it up. So tweet, please, and use that keyword in your tweet. So I'm going to show you the OpenShift console. Syndesis console. Here are all the connectors that we currently ship. But obviously these are connectors, so they don't have the credentials set yet. So I'm not going to go through a step of setting these credentials because I want to go do things quick. So I'm going to create an integration. I'm going to start with a Twitter connection, a pre-configured connection. Let me show you that this connection is actually live. If I go to the Twitter thing, I can click validate, and you can see that it's actually a valid connection to Twitter. All right, create an integration. I'm going to start with Twitter. I'm going to do a search. I'm searching for that keyword that hopefully you guys are using, SATURN 18. I'm going to pull that every 5 seconds. and then I'm going to push it to a database. So I'm going to invoke, again, I have multiple actions here. I can either invoke a stored procedure or SQL. I'm going to invoke SQL here. So I'm going to insert screen name, the name, and the tweet in the Twitter table. So I'm finished with this. So I have a start and a finish action, as you can see on the left, but I have a warning sign because I need to map data. So on the source side, you see that this is the Twitter API. So I'm going to pull text into tweet. I'm going to go into the user object, and I'm going to find name, the name, and screen name, the screen name. Okay, done. And save as draft. It's the SATURN 18. Integration, demo time. I'm going to publish it. So at this point, container is being, the integration is being built, so a Maven a command is being executed, and the resulting application is being put into a container and published onto my cloud that I have here on my laptop. So this is going to take about a minute, I think. So in the meantime, what I can do is use that time to log in to the database. So this is a list of the running pods. You can see the top one is SATURN 1 build. So it's building the SATURN integration. But you can also see I have a database pod here. This is a Postgres database. So I'm logging in. So now I'm logged into the container, and I can do PSQL -user sample database. Connected to the sample database. You can look at the tables in here. Yeah, there's a Twitter table. Select star from Twitter. Well, I'll select name, tweet from Twitter. Let's see. Let me double check how far we are in the deployment. Yeah, we have messages flowing. Does any of you see a tweet that they Twitter? Yeah. Yeah? Yeah. All right. Who's the one that said yes first? All right, well, that's the end of the demo. I still have 10 minutes, yeah? So the lessons learned, I guess I still have time for that, so I quickly can go back into present mode. In the beginning, we had a different Git repo for every pod. We thought, hey, let's separate everything nice out. That was really, really difficult because it was really got complicated to figure out what happened. So we went to a mono repo. We literally have everything in one repo right now. And it's awesome because we have one script and one command. With the one command, it brings everything up, compiles everything, brings everything up, brings up Minishift, deploys it, everything, and has the design documents. So I could really recommend a mono repo. Second thing is Java. Java tends to have a lot of overhead. So in the beginning, we had way more pods than we have now, but we consolidated. So in order to save money, basically, we reduced the number of pods that were running by consolidating some services into one JVM. So I think the business costs usually win over technical features. It is what it is. But if you tune Java well and you make sure you set limits on the pod, Java actually performs pretty well. But you have to set limits on the pod because otherwise Java, as a process, will ask the operating system, what are my memory limits? And it will give the memory limits of the host, which is way more than you're assigning to the container. And so the container could take the host down, basically. But if you set limits on the container as to maximum memory use and stuff like that, the garbage collector will just work that much harder. Third point, UX first. That actually worked quite well. I think our designs came out great and our implementation came out great, but it was always the bottleneck. So that kind of, I don't know if that was because, I don't know why it was, but it seems that team was swamped the whole time. On the UI side, Red Hat is not typically a UI company. So we don't have a lot of UI developers. And so we templated the hell out of everything. There's really not many screens, and we templated every screen, and we made them configurable. So it's really metadata driven from the back end as to what's being shown on the front end. Camel, we actually drove a lot of features upstream, way more than we expected. To make Camel more extensible, we needed to change Camel. So there were a lot of changes that went back upstream into Camel to support this. I would say that the Kubernetes cloud changes everything. It makes it super easy to start, but I think there is a learning curve, definitely, if stuff doesn't work. Like UI developers need to know who to ask. So you need to have some basic understanding of how things work. And so that definitely is a learning curve. Minishift for me was a lifesaver because it's that much easier to support it. You can wipe the whole thing, you can start fresh. Within 5 minutes, you have everything back. So if I didn't have Minishift, if I had to work directly into the cloud, I'm not sure we would have made the deadlines that we did now. So I would definitely make a point to use Minishift, or if you're on Kubernetes, to use a Minikube. That's it. Any comments, questions? Floor is open.
All right, let's say I wanted to put something, so you did a direct connection from a Twitter stream into a database. Let's say I wanted to put something in the middle of that, like a data transformation.
Yeah.
Would it be possible to show that, or could you, I guess, explain what the steps would be to put that in place?
I have a data transformation in the middle right now, right? That's, I think, make sure that you could see that. Right, the data mapper is in the middle, but you can add more. Yeah, you can add other actions or other connectors in between. No, it'd be running as in the backend in the same. You extend the Camel route basically, so you're running in the same integration. Yep. Most of the things come from the user thing, so I'll have to scroll down for that too.
Kurt,
Is that what you wanted to see? Yeah.
So you mentioned you didn't want to just create a UI for Camel, right? And but Camel does have like a lot of control structures and other patterns and stuff. I mean, are those behind the scenes, or can I do a when kind
They're
of a
behind the
thing?
screens.
They're behind.
And so if you want to, you can still use them if you're a Camel developer, you can still grab into them through extensions. So there's a whole extension framework here, customizations. It allows you to upload extensions.
So extension, so I could create my own processor and upload it here?
Yeah. So we actually have 20 extensions waiting to go already, but we didn't ship them because we like them as examples so people can see how to write an extension. So you can add a logger, so it logs the body of the message, something like that. I can show you quickly what kind of extensions there are. No, it's the second tab actually, here. So we have a loop extension, for instance, or a script extension, or a threads extension, or a throttle one, connector to Telegram, a timer, and then all the interesting things like database connector. If we can't ship all the JDBC drivers, for instance, Oracle doesn't allow you to do that if it's an Oracle database. So we have an extension to upload custom drivers. So you could upload your own Oracle driver. Yep.
Whose responsibility is it for things like reliability or error recovery? So imagine that while we're running that Twitter application, that the database, I don't know, runs out of connections and crashes or something.
Yeah.
I guess what would happen at that point? Like it
What
seems really thin, right?
Yeah. So what would happen is that in your integration, if you go to your integration, there's an activity log, and you can see that for every log, it logs what's going on. If there was an error, it would be shown here. And then if that's not good enough for you, you can always view the log in OpenShift itself. So in OpenShift itself, this is the actual logging of the component, of the container, the integration container. So I don't know, you can, if I scroll to the bottom, this is when it boots up. It uses Spring Boot to start Camel. And then after like 10 seconds, something like that, it's ready. And now here, every 5 seconds, it's polling and then putting stuff in the database if there's response coming back. So you would see a stack trace here. So that would be for the developer to then go and fix. Does that kind of answer you?
Yeah, a little bit. So I guess the question is, so that's okay from this perspective, right? But I'm trying to imagine, so I guess what you were running from the command line is the client, right? So if I were, say, in a web setting or whatever, it sounds like I would have to take care of like retry logic, for example, within the client that I'm writing to use the connections that we just put together.
Yeah, if you
there would be an error response, I guess, that I would be able to interpret in a meaningful way in that situation.
Yeah.
Okay.
Yeah.
Cool.
Okay. In the face of time, I'd like to thank Kurt for a good technical talk.
Thank you.